Hi, I'm Cressel Anderson. This is Makercise. In this episode, I'll be casting aluminum and bronze parts for the shaper yoke. One of the things I'm trying is for the sprue and kind of feeder sections, I've hot wired out little grooves or little channels in them, so that way when I cap them off, glue them together, the metal kind of has a place to go as well as a more clear vent out. I'm going to try to put a vent on the other side and arrange these things so that the byproducts from vaporizing this polystyrene hopefully make it up and out and make a little better casting to machine. I'm going to put a cup kind of angled this way. I've got a vent going this way and should have a little spot for a pour cup. In preparation to move, I packed my tire that I was using for the vibration table into storage, and so I kind of had to improvise with a spare wheel and my hand truck. It worked okay. This is how the casting turned out. I love lost foam. It's great. I mean, look at the dimensional tolerances on these parts. They seem very faithful to what I originally assembled here. Prior to applying the plaster of Paris, it does a great job keeping sand inclusions. The top runner, I think, was sized about appropriately, as well as the vent being placed well. I don't see any kind of gas inclusions or other debris in the actual parts. That looks real good. I also like using the wax as a coating. Take a look at this picture. This is from the engine of my car. I replaced this water pump just before I went on my road trip to Oklahoma, and you can see the same kind of details in the engine block casting as you can in this lost foam that I'm doing. So I think it's okay to have that texture, but it is cool to know that the wax application over the top is a really good way to kind of modify that surface finish. You probably even sand it down. The only drawback is the plaster doesn't seem to adhere particularly well initially over the wax. You can tell this one was done without the wax coating, and this one had the wax coating, so you've not got any of this expanded polystyrene texture on the one that I coated with the wax. Anyway, let's get these cut up and start making some shaper parts. It's fortunate that I have two holes here. It's hitting on the back on the hub portion of the faceplate, so I need to move the screws a little bit to the outside hole here so that I can get the faceplate clamps close enough together. I flipped the part end for end, and then I used these two squares. I pretty much just stuck them back up in there on the faceplate, so that way I could get the machined flat side on the other end of this block parallel to the faceplate. So that should make these two ends parallel. I'm facing off all the sides of these blocks that I cast for use in the yoke of the shaper crank mechanism. This will be the part that goes in the center of the column and oscillates back and forward based on the rotation of the bull wheel. Just need to flip this part around. This will be the first one that I have completed all four faces, or all six faces. This is my last one to do here. So. I got a little carried away on the one dimension there, so it's about 15 thousandths over that direction and about 20 under in that direction. I really need a graduated disc for the lead screw. Oh, I'll get that a little closer. Ah, there we go. It's only about 10 thousandths off from square on this end. 1-inch diameter. So I need a 3.14 inch dial. I think this is a 3/8 16 rod. I already faced off this end, and now I'm going to face off this end to make the overall length as called for in the plans. So this is the last one that I have to machine, and then I'm going to start boring holes. I think I'll do them all on the lathe because that's what the book suggests. I'm advancing the lead screw 10 thousandths between each of these cuts. This is about 6 inches of stick out from kind of where the set screw is on the faceplate. So I don't know, I'm happy that it's not giving me more problems than that. These are the support bosses for the little hinge rod that goes across at the bottom of the column. This will be the slide block that goes up and down and causes the yoke to oscillate back and forward, driving the ram. This will be the block up at the top. I've machined these two to the dimensions they need to be prior to boring them. Both these will have holes with bearings installed in them, as well as the top. The top I still have to thin up just a little bit. Once that's done, I'll mount these parts in the faceplate clamp, and I will bore them using the lathe, and probably have to bore them out so that they'll accept these bushings. I don't currently have a bushing that is wide enough for this part, so I think I'm probably going to have to turn that. I do have some raw bronze stock, so I'll probably use that. I might end up having to take a little bit off of my clamps. It's a little too far down in there. I could make taller parallels, but I think it will probably be faster, and it'll give me, to kind of clean up the tops of these clamps a little bit. So I'll probably just go all the way down to the line, even if I get into the angle iron clamps there. You can definitely tell that I'm getting into these clamps now. You can even kind of hear the difference in the sound that it makes. So that's the clamp. Second clamp. Go ahead and call this good enough. I mean, this works. This holds parts. But when you clamp stuff at the end, these bolts tend to kind of squeeze the base together and lift it off, and then it's not completely parallel. Coupled with the fact that these screws are so far out on the faceplate, the inside corners of these angle iron clamps comes out just a little bit, and I'm not so sure about my parallels. They may be off too. So anyway, this is a nice square piece of stock that's pretty much the dimensions called for in the book. So I'm going to proceed with it, even though it doesn't have exactly parallel sides. The yoke will pivot around this 12mm rod held between the two bosses. Thing doesn't look very well aligned, does it? Well, that is apparently not a very good way to get those holes centered up.
In a previous video, you saw me alloy up the C932 bronze. Today I am going to be melting that down and pouring a cylinder that I can then machine a little bit more readily than this ingot. And I will be making bearings for the shaper yoke. I think this is what happens when you leave your foundry out and it gets rained on. Probably all that ceramic fiber has some moisture in it. I've tried to let it dry out, but I guess it's going to dry out pretty quick at this point.
That's what we ended up with. This will become the bearing for the lower casting, this will become the bearing for the upper casting, and this will become the bearing for the slide block. And then I have a nice 1-inch diameter piece of bronze that I might end up machining as a lathe bearing. I try to keep the turnings from the bronze so that way I can remelt them and have more bronze for bearings in the future. I don't really have a tool that seems to be particularly well suited towards getting up in here. I've not got much of a part sticking out from this set of clamps on the faceplate, but I used that parting tool that I ground a while back and just kind of using that side corner of it to try to clean up this bearing. That's not any good. I broke off my cutoff tool, so I switched over. I do have a left-hand turning tool, but I don't know, it's really not set up for this kind of a cut, but it seems to be doing okay, so that's what I'm running with. This is going to be the slide block bearing, so I think this bit is pretty big. I'm not exactly sure what I think will happen. I think it may spin in the Morris taper socket. Bingo! That's exactly what happened. I was able to drill up to 12 millimeters. I just had to go in smaller increments. I went 6 millimeter, 8, 10, 11, 12. And so this shoulder bolt is at number 12. This is for the crank pin. It's just a little tight, so I think I'll have to get out the boring bar and open up this just a hair. I think the old boring bar did the trick. It's a pretty good fit. I'll make a mandrel and then turn down the outside of this face off the other end. I've turned down this shaft to where it's pretty well about 1/1000th under 12 millimeters. These bushings, as well as the ones that I cast, are 12 millimeters. So we'll see how well they fit. Pretty good fit. Now I can super glue these bushings onto this arbor and turn them down. Leave a little bit sticking over at the end so that way I can face it off. I took the shims out from under the front of the tool, and it makes the rake angle a little more shallow, and it seems to cut much better. You can still really tell the flex in the carriage. I think the majority of it is coming from the interface between the cross slide and the compound base. This is really putting a hurting on this lathe. That thing is hot too. Let it cool down. Not to mention the fact that the heat has caused the super glue to let loose, and this bearing has ridden back down the arbor. Woo, that's hot. I faced off the end, and now I'm going to give it a little chamfer. There was some pitting in my castings, but I think it'll do all right. This is the bearing that will go in the slide block, and for turning that bearing I just used an aluminum arbor to turn it. However, for the case of the upper end casting bearing, which is I think the book calls for a 1/4 inch by like 3/8 inch bearing, I couldn't even find one of those in stock. For such a small diameter arbor, I went ahead and made it out of steel. So I've gotten a little braver on how much to take off. I do a full 25 thou cut on this, trying to reduce the diameter of this rough casting down to what I need. And that gets pretty hot. So I got that hole a little bit bigger than I wanted, but best I can tell, pretty close. I used my calipers to mark a center line along this top casting, and then I marked up the required distance along the side, and then I used just a small hammer to kind of tap this thing around while the bolts were a little bit tight until I got the center of those two marks pretty well aligned with this center drill held in the tailstock chuck. This is the way that the book recommends it, because the book was written under the presumption that the reader doesn't already have a drill press. Drill presses are so cheap nowadays that, you know, a little drill press like the one I use all the time, just it doesn't make sense not to have one. I'm just showing this technique to give you an idea of how it would be done based on the book's recommendations. This bushing had a little bit of untidiness around the inside of it, and when I pressed it in with the vise, boogered up this end, so I'm going to get rid of that using a countersink bit held in the brace. If you enjoy this project, do me a big favor and go ahead and click that like button. In the next project video, I'll be assembling the yoke and connecting it to the ram. I hope this project builds your confidence to exercise your inner maker. Thanks for watching.